this, right? And this will be something that happens quite a bit on the AP exam. And this is what makes those multiple choice questions so difficult, is that you have to kind of refer back here and there. So if we look at the credit, these are kind of, some of these are tricky, and I want you to understand that I'm just throwing these out at you because A, they're going to be questions like this on the AP exam, and B, it will prepare your mind for the more specific questions that I'm going to ask you. So essentially, if you understand these, the multiple choice questions that I'm going to give you are going to be super easy. All right. So how many different constructor methods can be invoked by a MasterCard object, right? This is more of a thing where where I want you, when you get, by the time we get to the test, I want you to understand what you have access to and not by the different classes and subclasses, right? So if you have a MasterCard object, that's this one here, and it extends credit card, so it has all these. And remember, it says non-constructors, right? So you get these three, and then in addition to that, you get a fourth one. So the answer there is D, right? We get access to 4. Are there questions on that? That one's pretty straightforward, but if you have questions, please ask now. Okay. Default constructor. So the correct implementation. So obviously 2 and 3, you don't have to necessarily set rate equal to 0. It'll still compile. So basically the question's asking, are these going to compile, right? You don't necessarily have to set rate equal to 0. What's wrong with number 1? Yeah, so call to super, if you're going to make a call to super in a constructor or in a constructor anywhere, right? Your call to super has to be the first line of code. Okay? You can't do something first and then call super.
Super like with the constructor or without the constructor?
Doesn't matter. Any call to super in the constructor has to be your first line of code. Okay? Cannot do that. So that's basically the premise. The other thing you should probably understand is that you could do this and it would compile and be okay. All right. Correct implementation of the constructor with parameters. This one is a little bit weird. So does that implement the constructor? No, because it's a subclass, right? We have to pass data in order to get any of this stuff. We don't have, I don't think we don't have access to current balance. I think we have access to rate from MasterCard because that's where it gets, isn't it? Yeah. So we have access to rate, but we don't have access to the current balance. That's just dumb, right? You can't set a method equal to a thing, to a double. So we're wrong there. This one is a default constructor, so that's out. Constructor with parameters only takes one parameter. So D's really our only option, right? It's the only correct implementation. Do we have questions there?
What if we set up, okay, what if we set rate equal to something and we call super with rate? Like, is it going to be saying rate is equal to 5 and then calling super with rate, or is it going to be saying?
You can't do that first. You can't set anything. Like I said, that call to super has to be the very first line in your constructor. Yes. It's not the best idea to not assign the value, but you can get away with it. It will still compile. So yeah, it's not the best implementation, but it still works, right? Did that answer your question, Arvin?
Kind of, what what if we have like a very diverse program here? Taking this, we are asking, how do we like, how do you explain that for the very diverse program, which has a meaning, this is a final variable, and then a range we gave it.
Okay, so that's different because we're not actually changing the original value. We're adding onto it in the new subclass, right? You can't go back into prename. You can't change the value of prename, right? But you can take a name and add something onto the prename to create a new name. So that's a little bit different. We'll go over that in a second. Okay, we'll get to that. So that we're clear on that one though, yeah? Okay. So the Amex constructor requires a double input, right? It does inherit a default constructor from the superclass. So we actually didn't need to override that. So we can actually get away with we can actually get away with number 2. I think that's the only confusing part, because most of these are pretty straightforward. We don't actually have to call super there, right? Because there's a default constructor. We don't even have to touch super at all, right? We don't need to pass data. We don't need to do any of that stuff because we have that default constructor. We still get the only thing we need when we're creating the Amex object is that we need to do something. We need to initialize the balance to something, right? If we run make payment, that gives us a balance, yeah? Or I mean, it subtracts from a, yeah. Maybe that's not exactly the, you would probably use charge there. So that's actually misprinted. So let's just change that. So if make payment, you shouldn't need to use super dot, because the difference is that it's public, right? So charge and make payment are both public. Yeah. So if we inherit them from the super, we can call them directly. We shouldn't need to call super.
Yeah, but it's overridden in Amex, so we wouldn't call it from Amex.
So it's overridden in Amex, but same thing, right? Same instance variable. Well, all we have to do, so we have to call, let's see, hold on. So we're passing data. Let's see. So if we're charging that amount, yeah, so we shouldn't have to call super there, because if we're making an Amex, right, object, we want to pass data to the one that we're using for that object, right? We don't really want to pass to the super. In that, yeah. Correct. And there might actually be a call to super in here. We don't know what the implementation is going to be, right? So we could have a call to super there and then add some additional functionality onto it, but it's not what you want to get in the habit of doing when you're on, the test that you're going to take from me should be pretty straightforward with all of this kind of stuff. But when you're on the AP exam, you kind of want to not overthink it too much. You just want to focus on, is that going to compile, right? Is it going to go? Most of the time, if there's some ambiguity in the question, if you just focus on, is it going to compile, you'll usually come up with a correct answer. Let's see. So charge method in the Amex class. Which is the correct? All right. So what's the goal? So let's take a look at what the goal is. We want to charge a cash fee of $20, right? If we're doing a cash advance. The way we tell if it's a cash advance is there's a Boolean. So that's going to be true or false based on what we get as an input, right? So again, if we're going to call super, that's usually first, right? We're going to charge. So we can do this. This is probably the most efficient. If that's true, we're charging another cache fee. I believe that one's good too. What's the actual question? What is the correct implementation? So I suppose calling super there. So if we call super there, we don't have to create any new functionality, right? So in this instance, correct is probably what I would say most efficient, because we don't have implementation for that, right? We don't want to rewrite implementation. So we want to make sure that we're using the one in super. Would be the one I would say. So if cache, so this is the only one that actually reuses what we've already written in super. If we do it any of these other ways, we actually have to write implementation for charge, which we don't want to do, right? We want to use what's already there and then add on to it. Questions on that? Yeah, if you didn't do it, it would also recursively call itself unless you wrote the implementation to stop it, to shortcut it somehow. You'd have to write implementation that sort of short circuits it. Definitely want to call super there. More questions on that one, or are we good? I'm not going to give you that. I'm not going to give you like anything. These are mental exercises more than anything else. I'm not going to give you anything that difficult on the test. If so, in the charge method is being redefined in the Amex class, right? What's that example? An example of?
Redeclaring something, so it's like overriding something.
So we're overriding, right? We're taking an existing method in the super, and we're changing the way that it works. Overloading is different. That's when you have two methods or constructors that are in the same class, right? And you are, the only difference between them is what the parameters look like. It could technically be dynamic binding, right? If you overthink it, but the reality with this one is if you're only given a choice of one answer, dynamic binding is basically the result of this, right? So we don't really want to we don't really want to get too far into that, because technically this is just method overriding. You are definitely going to, when it compiles, you're definitely going to experience some dynamic binding, but that's not exactly what that is. Questions on that one?
Well, the choices in the exam would be dynamic.
There probably will be some. You have to be very sharp as far as.
So will people like protest the grading of the AP exam because?
You're definitely not going to be able to protest the grading of the AP exam. It's a private company. You can either like it or don't.
Yeah, dynamic binding to works, right? So why not?
Because doing this, right? Redefining that method is not itself dynamic binding. Definitely dynamic binding will result from that. Yeah, but it's not the thing itself. All right, these ones are question 7 is the one that I've by far gotten the most questions on. And if you look, all of these objects that we created have a type of credit card, okay? So the reason that you would do that is because you would want to be able to take a MasterCard, right? A MasterCard and an Amex and whatever, all your different credit card types, and put them in the array list so you could run some type of function on them, right? Usually, if you were going to do that, you would want to be using functionality that's common between all of them, right? So I'll give you an example. Let's say I'm the CFO of Chase Manhattan, right? And I want to run a quarterly report that shows all of our holdings, yeah? If I wanted to do that, I would group those all into some sort of a list, right? That are all credit cards, and I would run net balance on them, right? I don't need anything else from the MasterCard class in order to get my net balance because I've already inherited it from credit card. So I don't need any of those specific functionalities. I just need to be able to grab that object and put it into my array list. So this causes an error because accrue is specific to a MasterCard object. And even though the reference in this case is a MasterCard object, right? Your object type is credit card, so you do not have access to the accrue method. Questions? All right, let's move on to 8. So what's polymorphism? Right, when one thing takes a bunch of different forms, right? So make payment, is that in a different form? It's in a different form nowhere. It's part of the superclass. Accrue, is that in a different form? It only takes place in one place, so it's not taking different forms. The constructors, no, because they're common between everything, right? Everything's inherited. Is there an overridden constructor? I don't remember on this one. Let's see. Doesn't look like nothing's overridden, right? There's one where we pass data, but nothing's overridden. Where to go here? All right, so charge is also nothing, right? Actually, charge is the net balance, make payment are both the same, right? Charge is the one that's overridden in the Amex class, right? So it's taken at least 2 different forms. So again, you're testing polymorphism anytime you take a method that's inherited from a superclass and you change the way it works in a subclass. Yes? That's right, yeah. So got it. So that one's changed. Did you guys hear that? I mistakenly put Amex there. It's actually only defined in the MasterCard class. Can't be invoked by a credit card object. Let's see.
Wait, why not? Like credit card is like a superclass, right? So
Credit card is a superclass, but it does not have the accrue method. Yeah. So a credit card, so MasterCard is a credit card, but a credit card is not necessarily a MasterCard. Okay. Which of the following would not cause a class cast exception? What's a class cast exception? Anytime that you try to cast something to either, anytime you cross cast, which means you can't cast one subclass to another subclass, right? Because they're completely different usually. Well, not completely different, but there are enough differences that makes that problematic. So we can't say We can't necessarily upcast. There's certain situations where we can upcast, but this is not one of them. So we can't cast a MasterCard back to a credit card, or we can't cast an Amex back to a credit card. We can do that because A is already an Amex. Can't do that. And we cannot do that, right? So let's double check these, right? C, the reference is a credit card object, right? So I can't upcast that to, or I can't down. What am I trying to say here? I could downcast that actually to a MasterCard. I could cast that into one of the subclasses, right? Downcasting is okay. If I have a MasterCard object, right? If my reference is a MasterCard, I can't upcast to a credit card, right? This one's already a credit card, but I wouldn't necessarily be able to do that, right? Let's see. So the answer is C, because even though A is an Amex, right? Even though the object type is credit card, the reference is an Amex. So I can downcast that to an Amex. So the better explanation of that is here. That's a pretty good visual of what we're doing. Do we have questions on that one? Okay. So we're adding a new method called transfer to the credit card class. All these declarations, why are they all correct? Or all these, so we have these declarations, we have all these objects. Why are all three of these correct? We only really have to check two things. We already know running transfer is okay on all three because it's getting inherited from credit card, right? Now all we have to check are what parameters do I need? I need a credit card object and a double amount, right? Credit card object, double amount, credit card object, double amount, credit card object, double amount. We're good. All three are good. Questions on that one? All right, I think we're good there. One more thing I wanted to go over with you guys, and I actually wrote this down for you the last couple of nights. So I want to make sure that you guys are 100% on the big thing here is a versus has a relationships, right? I'm going to, that's there. All right, so let's go. So inheritance, right? When you have superclass subclass relationship, right? That is a relationship, right? A MasterCard is a credit card. And that creates, different kinds of polymorphism. There's another kind of relationship between objects, which is called composition, which we've covered briefly, but I want to make sure we're not shaking on that before we go into the test we're about to take and the AP exam. So composition is when you have an object, right, or a class that contains or is composed of other objects. And the example here is like a car, right? I could have a class called car that is composed of engine, transmission, and suspension classes, right? You declare those objects inside the car class and you make them part of part of the car. Okay, so you can do stuff like this. You can declare class car, have engine, transmission, and suspension objects, and then you can run different programs on them. The example here uses public instance variables, and you can see how that works. Most of the time, if you see it in other areas, it would look something like this. So I have this class car, and I have all my data members are private here, right? I have a name for the car. I have engine, transmission, suspension. I'm importing the string for name, engine object for engine, transmission object for transmission, suspension object for suspension, right? So now my car is composed of all these different types of objects. I called void upgrade, right? Or I called this the modifier upgrade. Why didn't I include the name in here? In the modifier. Why didn't I include name there? If I have a Corvette, right, and I modify it somehow, is it still a Corvette? Still just a modified Corvette, right? So that'd be an example of encapsulation, right? I'm excluding certain factors that I don't want the user or other programs to have access to. So obviously I have what do you call it? Accessors here, and I have a toString. And if you pay attention to the toString itself, I'm just getting the names of my stuff. Again, my toString is just basic information about the object, right? So I created engine class, all right? So I can create objects from that. The other thing I want to do is create suspension and transmission, right? So this one, I'm just going to change suspension. And those all are pretty similar. They just have names and types. Oh yes. Save that, and then instead of engine, everything else should be the same. Just have name and type, right? So over here, I could have a main method. I could create engine. I'll create a new engine object. What should the name of it be? Let's say we're making a Corvette, so LS. What are we up to on the LS? I think it's like an LS9, and type is a V8, right? Transmission. I don't know that much about transmissions. I'm just gonna call it good transmission, and transmission is whatever. Suspension. Let's call it equals new suspension. I'm gonna call it sport, and the type would be, let's say, independent. Okay. Then I could create a Corvette object. And I can say engine
You need to do it, right? You need to do it, right?
I think I could run that safely.
You already did it?
Oh, I screwed everything up. Gonna find symbol. All right, so I promise that works. I'll show you guys the rest of it next week.